Hi everyone, welcome to another episode of GCS Connect Leaders Series. We've got Andrew Strain joining us today, and he's the CTO of AAC Clyde Space. Really interesting company, and I had the pleasure of speaking with him about some exciting parts of their business and how their work connects with our daily lives. Him and his team are doing some really innovative work with satellites, collecting data, and building software that is really pushing the space industry forward. Enjoy. Good morning, Andrew.
Good morning.
How are you today?
I'm good, thanks. How are you?
Yeah, very well, very well. It's Friday today. Obviously, we won't release this on a Friday, but it's always good to have on a Friday morning. Everyone's in a chipper mood. So welcome to everyone, to all our listeners on the Leaders podcast. So we've got Andrew Strain with us today. He's the CTO of a business called AAC Clyde Space, that work within the space industry. We're really excited to have them here. They've got a lot of really interesting kind of tale to tell. Andrew's got 16 years experience in the industry as an engineer, kind of rising up to CTO and really growing alongside Clyde Space, which is similar to my story at GCS. Both started at the kind of the bottom and grew with the business. I think they call us intrapreneurs, Andrew. We've helped to kind of grow the business together. But yeah, tell us a bit more about your role. Tell us a bit about Clyde Space and what the business itself does.
Sure. So we're a space company, and the part of the space industry that we mainly operate in is kind of known as new space. And the idea behind that is we're looking to try and be a little bit more low cost, cost effective, commercially focused in the space industry. So rather than launching satellites that cost billions and billions of pounds, and them staying up there for 20, 30 years, we're looking at a much smaller scale of satellite going into low Earth orbit, lasting for maybe 3, 5, 7 years. And we're using kind of newer technologies and things like that. So my role within that is to look at what technology do we need to deliver the types of missions that we're trying to do. We're looking at different types of data that we can get from low Earth orbit, different types of ability to move the satellite around, more processing power, more power in general. Everybody wants more, and when you tell them they can have it for less, they still want more. So we're looking for what do we need to do next to try and kind of push the boundaries of what's possible in the space industry. My role within the group. So we have 6 companies in the group across the globe. We've got Glasgow, Uppsala, Gothenburg, Fairfax, Cape Town, and Delft. And we have a range of different capabilities. So some of our sites are very focused on subsystems, so bits of satellites, and some of the kind of building blocks of the satellites that we would put together. Some of the sites are looking at the full mission, how we get it into orbit, how we get the data down, how we run the satellites, and how we then deliver that to the customer. So I look across all of that and see how do we tie all of those different technologies together to give us the best solution possible across the whole thing.
So when you joined the business, Andrew, obviously what you were doing at the time is what Clyde Space was focused on then, 16 years ago, similar to what you're doing there? Has there been a kind of journey of progression, or could you have foreseen that?
I think it would have been difficult to foresee it, and it's changed beyond all recognition, really. And that comes from the fact that when we started out, we were I think the second company in the world looking to commercially deliver parts for CubeSats, which is the very small satellites that we build. The kind of 10 by 10 by 10 cube is the smallest size of them. And I think the reason that it's changed so much is that concept came from a couple of guys in universities in the United States who were looking for a way of getting people involved in space and teaching them how to build satellites before they were going out into the kind of the working world. And they came up with this standard to allow people to try things out, build satellites at a kind of lower cost approach. And there were missions being led by universities in the United States. So what we were doing was we were supplying bits to those satellites. The power systems was where we started, and we kind of fed that through. And then over time, what started to happen was people started to do useful things with those satellites. So rather than just being a learning tool, it was like you could get useful data, you could get scientific information, you could use them as a technology demonstration, because it was much cheaper to launch one of these satellites than it was to get a new component and put it into a really expensive satellite and not trust it. People won't do that. They want heritage. So you were able to use these satellites for useful things, which meant that the kind of the institutions, your NASA's, ESA's, people like that, started to look at it and say, okay, there's an option to do something here. So our customer base changed from universities to some of the institutional places, and a little bit more rigor would go into the types of things that people were looking for. And through that process, we also looked and said, well, we started off with power systems, but actually what we want to do is we have the capability, and there's nobody yet developing and delivering full satellites, or very few if there was any. And we kind of looked at what else do we need to do, what other systems do we need to be able to grow that capability for ourselves, move ourselves up that kind of growing value chain. So we did that. We built a satellite. We got some partners, some funding. Went through a full mission. Delivered that to orbit. And then after we'd done that, we started to see that commercial people were starting to look at it and say, well, actually, if you can do useful science and technology demonstration, can you actually gather data that you can sell and do commercial applications for this? Because it's a whole other business model to traditional space. So our customer base has changed from universities to institutions to, and there's also a kind of defence military element to it sometimes. They're looking at it and saying, how do we use that? And our supply of capability has changed from subsystems to missions to subsystems to platforms to missions to delivering data. So we've kind of moved ourselves up the value chain as the industry has grown around us as well. So everything's changed essentially. We're still based on the same ideas and the same approaches and development of the same processes, and the ideology that we follow, but completely different customers, completely different uses for the satellites, and we're always kind of pushing what's next and what can we do, and how do we make it useful.
Yeah, it's really interesting. I guess when I think about it, you think about it all the time, but you've obviously progressed. You said your second company doing this type of technology, so you've obviously progressed with that. Are the other company that were doing it at the time still around? So they still the competitor?
They're still there. Yeah, they're still there. They're still there, and there are a lot more. It's a lot more competitive than it was back then.
Yeah, that's the market, that sort of thing. And as a leader within the business, and obviously, I know this. Like, you start with the business grows around you, so you become a leader. As being to be hired as a leader. What sort of challenges has that given you? You're working in an area that's constantly evolving. That is the new frontier, as it were. We can use a Star Trek analogy, if you know what I mean. But how does that change what you've done as a leader and how you kind of presented the technology to your team and to the people that you're working with?
A lot of it is around. There's nobody to tell you how to do it. You can't sit around and wait and expect somebody to say, this is the rules, this is the boundaries that you're allowed to push to, and this is the box that you live in. Our industry, and for me, it's never been possible to do that, because when you're at the front of something like this, people haven't done it before, so you have to learn and figure out and try things and do things that maybe other people haven't done. You need to look at the risks and balance them against what it is you're trying to do, and try and find that sweet spot between doing enough engineering and using enough new technology in a way that's going to be reliable and actually deliver. And we can pull on other industries, and we can pull on traditional space industry as well. So in the kind of European market, there's the European Space Agency is kind of the umbrella that everybody looks to. They've got a whole set of standards, but those standards are built up over decades of doing space missions in a particular way, whereas we're trying to do something that's not quite the same as that. So there's loads of things that we can learn from that and we can tap into in terms of processes, technology, all the rest of it. But we have to be able to look at that and say, question it. Why is it that you've got that? Why is it that you've done that? What's the reason behind it? Because it might not all be applicable to what we're trying to do, and trying to balance and assess those things, and then select the technologies that satisfy the kind of need of what we're trying to deliver, but also taking the learning from other industries and sort of merge that together is a real challenge. And then trying to find people to kind of bring in, and there's not always the resource pool. When you're at the forefront of an industry, you need to tap into other industries. You need to tap into people who have got transferable skills. You need to look at it, and you need to grow the people as well. So you can't do it all on your own. And I mean, we've gone from, so I mentioned earlier, I joined about 2 people. I think there's about 180 people in the group now. So I kind of found that when you pass about 30 people, like you get to a company size of about 30 people, you can see everything, and you can control it by person, and you can guide, and you can lead, and a lot of it's people to people based. And then when you pass that point, you can't see everything anymore. You've got to be able to have the people around you to delegate off to let them go and run with something, but trust that they're doing it in the way that is what you've learned you need to do in this kind of burgeoning industry. So it's kind of that's a tricky transition as well. So we've been through that where the technology needs to grow, the team and the way you work needs to grow as well, and that's really challenging. And it's really challenging to let things go as well. Like I'm a little bit of a control freak on that.
You and me sound very similar in both of our experiences and that sort of thing. And it's true that you're going to get to a point where, as a leader, you have to, give responsibility, you have to delegate, and you have to learn when to kind of get involved and when not to get involved, but still kind of keep that vision and that strategy ongoing. And what particularly interests me about Clyde Space is obviously talk about the engineering side, which is obviously kind of the nuts and bolts of putting satellites together, but also the kind of, from speaking to people in the business, is also now tracking on the software side and the data side and, data point side. Has your role, has your role kind of changed? That you said you kind of came into the industry as an engineer, but now obviously you're doing a lot more on the software side. Has that been something you've had to retrain yourself and understand, like, right, this is a different model, different type of way, or hire different people that can have different ideas?
Yeah, absolutely. I mean, I would hold my hands up very quickly and say I am not a software engineer. We use a lot of software, but I'm not a software engineer. And it is a very different skill. It's a different way of working. So, I've had to learn how software interacts with the hardware that we have, how the whole system works, and we've got, ultimately we end up with a system of systems, and software is a big part of that. And software in our organisation can mean a whole different layer of things. But what we've been really lucky with is putting together a team of people that do understand it. And we've got some really good guys in the group that I can turn to, and I can delegate that, and I can say, right, guys, this is where we're trying to get to. This is what we've got. This is the next thing that we need to do. And software is a key enabler in a lot of that. In our mission delivery and our data delivery as well. And again, it's quite different software that we need, but having the right people to talk to in the business to be able to kind of say, right, this is the overarching view. How do you help us get there? How do you fit into that whole picture to deliver the overarching view? So that's the kind of approach that we've been taking to that.
Yeah, and like you said, that's about the delegation, isn't it? Having people that you trust and working together collaboratively. One of the things they talk about a lot in software is obviously kind of agile, and I'm just quite kind of interested in, when you send something into space, obviously there's so much investment, you can't really be quite as agile. I assume you could be agile maybe on the software, but at some point you have to say, right, here's the satellite. Let's put it into space and see if that works. I mean, what is the process then? How does that work?
So it's when I start to talk through this, I sometimes realize it's actually quite complicated. And you're going to see the end result, but there's an awful lot of layers to it. Like we have in the organisation, we have a whole load of different engineering disciplines, and we need all of them to be able to deliver an entire mission. So we've got our missions team, and they'll look at the what does a customer need. They're looking for a certain kind of data. Maybe they're looking for images, or they're looking for some IoT data or something like that. So they've got a need. Our missions guys will look at that and they'll say, okay, so what do we need to deliver that? How many satellites? What orbit do they need to be in? What kind of coverage do we need? What sort of repeat time do we need? How many downlinks do we need in a day to get all the data down that we need? And it's going to vary from mission to mission. So those guys will look at all of that. Then they'll look at, in order to do that, what needs to be in that satellite. And all satellites, irrespective of the size of them, need certain things. They need power. They need a computer to basically tell it what to do. They need attitude control. So they need to know where they are, where they are in the orbit, where they're pointing, where they need to point, and how to get there. They need memory, they need radio links, and they need to survive. So we'll look at all of that, and that's a kind of platform, and that's the bits of the satellite that's common across. If it's a CubeSat for us, or a geostationary telecom satellite, we'll have different versions of it, but the same kind of fundamental blocks. Then we'll look at how do we fit that in the box that we need to get it into to be able to get it on the rocket to launch. So the systems guys will look at that. They'll look at it with the mechanical team, who'll look at, okay, how does it survive the environment? We need to get it up on the rocket, so we need to survive vibration. We need to survive, once we're up there, vacuum of space, the thermal environment. So we'll do a whole load of analysis on that. And parallel to that, we're doing a whole load of control electronics, control systems and our attitude stuff. We've got models. We simulate the orbits. We simulate where the satellite's pointing and how we can get it to where it needs to be. So we do all of that, and we generate some software off of that. We then go down a layer into those subsystems, the power systems, the onboard computer, the software, the radios, and we look at what do we have in-house that we can use, what do we need to design, what do we need to buy, and we're looking at how do we make sure we deliver the best mission possible. If it's something that we can use to add value specifically to what we're doing going forward, then it may be something we want to keep vertically integrated. But if it's something that's very specific to one mission, we might buy it. We might say, okay, this mission needs a specific kind of camera payload. We'll buy that camera payload, and it will give us the data, and we'll do the rest of it, and we'll deliver the mission. Then we'll do manufacture. So we actually build a lot of the stuff ourselves. We outsource some supply chain stuff in terms of component assembly where it makes sense, but we also have the capability to build it in-house. We then build the satellite. Sure. We then we'll go through a whole environmental test campaign, so our assembly, integration, and test stuff. We'll build the satellite up. We'll put it through vibration testing, thermal vacuum testing, thermal cycling, creating the Earth's magnetic fields, and trying to simulate that to prove that our simulations and the control stuff work when we put it in hardware. We built it right. Then we need to get to putting it on orbit. So we'll have to engage with licensing and frequency coordination and all that kind of stuff. Then we'll work with a launch provider. We'll get that launched, and then we've got our operations team. And our operations team are then looking at how do we run that satellite? How do we get it to do what it needs to do once it's on orbit? How do we schedule it, monitor the health of it, and all that kind of stuff? So they're getting the data down, writing the script, scheduling that, and getting every time it passes, getting the data down or scheduling where the data is going to come down. And then, obviously, all of that and that complexity, once you're up, still not going to be perfect. So to your point of being able to change things, what we've generally have done is we've designed a system that can have patches. We can patch software, we can make updates. Yeah. So if we for example, if we were to put the satellite up and we find that in the orbit that we're in, we're actually getting some of our sensors are blinded by the sun, or our mode of control is not quite giving us what we want, we can send up patches to the software. Now, we need to be relatively safe on that, because we will have a ground-based setup where we can try it out, make sure we think it's going to work, then we can send the patches up. So we've designed the system to be upgradable. And that's one of the things that is why software is really important, is once you're up there, you can't change the hardware, but you can tweak things and you can do things and you can try.
You haven't got an astronaut. You haven't got an astronaut in there, kind of, who can do stuff, have you? Kind of, it's like sending a mobile phone up there. I guess slightly bigger mobile phone, but like saying an iPad up there, I guess, isn't it? Really, that's what you've kind of got up there, isn't it? And you've got to make sure that you can kind of move it and play with it. And I think that's really interesting. But also, what from the conversations we have with Clyde Space is also, that industry, the impact that it has on our everyday lives. Because some of the projects that you actually guys work on are really quite kind of important, really, aren't they?
Yeah, I think people don't always recognise how much they use space every day. And like, people talk about space as this kind of abstract idea. And when I was kind of coming through university and stuff, they see space as astronauts launching from Cape Canaveral. And it's not. There's so much more to it than that. It's, people say that kind of thing, and then they look at their mobile phone and your little blue dot on maps. That's coming. Your GPS signal's coming from satellites in space. It's not our satellites, to be fair, but those things touch your life all the time. Telecom stuff is there all the time. The end of the market that we're in is finding its uses. And one of the things that's really important, I think, is figuring out for us in our industry, how do we add value to the entire space ecosystem and how you're using space? So we can get certain types of data that other people can't get because we're in low Earth orbit, because we have really high repeat times, because we can put constellations of satellites up for the cost of what would traditionally have been a single satellite. You get different data sets, and you can do monitoring. So we have a mission just now that we worked with the University of North Carolina, Wilmington, and NASA on ocean color monitoring. So they're looking at algae blooms and coastal erosion and things like that. So they're gathering data about these scientific large scale environmental impacts of things, and you're doing that from a satellite that weighs 4 kilograms, and you're getting images that are scientifically important and relevant to that community. And previously, that data would take a satellite was probably maybe, I don't know, a couple of 100 kilograms, and this little thing can do that now, and it just changes the types of data you can get and the speed you can get it at as well. So we are creating a kind of a different capability that uses the space environment as well, that's starting to add to these things. The other one that's quite common and people are looking a lot is IoT. You've got sensors all over the world, and when you're in a metropolitan area, you've got Wi-Fi, you've got phone signal. It's all very easy, but if you've got things in remote locations, it's not so easy. So how are you getting those signals back? You're not laying optical fiber cables to every point in the world, but satellites can give you that. They can give you that kind of that data throughput, data collection that you need, and that kind of thing is where we are finding that we can add a lot of value to what people are trying to do, and how the kind of the whole use of space is changing.
Yeah, sounds like something I need in my back garden because I can't get any Wi-Fi or mobile out there. I guess that would be a bit expensive, but no, I mean, I think what I guess you're seeing then is that real changes coming out of the future business landscape. Like we said, this has all been to me about a journey from a business that was at the start of an industry to a business that's leading that industry, and you guys must be so excited about what the future brings, because it's not going to stop, is it? This, the use of space is limitless.
No, it's. I mean, every projection that I've seen is always that kind of hockey stick shape. It's like it's all exponential growth. It's all more use, more capability, more satellites, more, and that comes with its challenges as well. We need to be conscious and careful about how we use space. There's always quite a lot of chat about space debris when it comes to low Earth orbit and these things, and you have to be responsible, because if we put things up that become space debris or are not controlled or planned, it essentially just ruins the industry for us. We kill the resource that we want to take advantage of. So I kind of, people talk to us about that and say, "Oh, but are you not just space debris?" It's like, why would I want to be space debris? I want to use that capability to deliver my business. I want it to work as much as anybody else. So we do things in our technology to make sure that we're planning correctly, we are controlling it in a way that we get the best out of what we've got, and then when it's coming to end of life, we get it out of the way, or we have a plan for what's going to happen with that, because then we want to be able to put the next technology up in the next generation of satellites, and the higher resolution images from the small sats, or the next communication protocol. We want to be able to use that, so we don't want to ruin it either.
No. It's your, it's your field, isn't it? It's where you work. It's your kind of workplace in some ways, isn't it? My last question has been a fascinating conversation, Andrew. But for someone that wants to kind of work for Clyde Space or move into the space industry, is this something where you have to be a rocket science? You have to do this type of thing, or is it something that there are transferable skills, or you can start, earn and learn your way into the trade?
when I started, I hadn't worked in space and I hadn't studied space at university, and I came from an electronics background, and we use
Yeah.
electronics. Software is used in lots of different industries, and actually, a lot of the time, one of the things we want to do is we want to look at it and say the space industry is not the biggest industry in the world by any
No,
stretch of
no.
your imagination. There are other industries that have done things well, and I've learned a lot of things that we can take benefit from. So there's loads of transferable skills. Um,
Yeah.
there are times where it's important that you're looking for people that do have space experience, and you know, when you're looking for a level of capability, there are some things that are quite niche that take time to learn, but there's also other routes
Yeah.
in. There's lots of routes in, and you know, from my experience working with AAC Clyde Space when we started, there wasn't an industry in the area, the geographical area we were setting up. We had to take people that weren't space industry and we had to work with them and get them to where we needed them to be. And I was one of those people. So there's lots of different routes that you can go to get into it.
Yeah. And are you proud to be a kind of a leader of, you know, obviously there is quite a large space industry in Scotland, but you proud to be a kind of leader in that particular location?
Absolutely. I mean, it's probably one of the things that I get the most pride out of is the fact that I look back at when we started and there was really very, very little. There were pockets of things going on, and now we are seen as a kind of a leader in the world in terms of what we can do in the space industry, and we get called out as an area that builds so many satellites. You know, at one point we were talking about the fact that we built more satellites in Glasgow than anywhere outside of Silicon Valley in the world. You know, so to have
Yeah.
helped create something that has that kind of impact and adds that value and is that interesting is a great source of pride for me.
Yeah, fantastic. Well, no, it's been great to speak to you. I could speak to you all day. I mean, I kind of feel like, you know, there's so much interesting stuff to learn, and it's been a fantastic conversation. And I'm sure our video editing people will stitch this all together. But what people don't know is that I poured all coffee over my laptop halfway through, so we had to stop. But you know, we're so professional, Andrew. We managed to kind of go through with no gaps and no glitches. So yeah,
Yeah, I'm sure it
so
was
it's really good.
seamless.
So thank you very much. Yeah, so thanks very much for your time today.
No
Great to hear
problem.
more about your journey and also Clyde Space journey, and also, you know, get an understanding of what the space industry is going to kind of do in the future. So thank you very much, and
No
thanks for your
worries.
time today.
Yeah, thanks for having me.